Problem-solving QC story from Fundamental Technology, 2. Sealing, with narration. Background of the problem. Hello. First, let me explain the background of this problem. In the market, there were several cases where the engine overheated during driving. We checked the basic causes first. Coolant leak none. Thermostat failure none. Water pump problem none. Then we took the engine apart and checked inside. We found a small hardened liquid gasket piece, foreign object, in the cooling system. This piece blocked the thermostat inlet, stopping the coolant flow. Poor cooling is directly related to engine reliability and safety. So, we decided to make improvements by following the QC story method. Current situation. Next, let's look at the current situation. The failure rate was 2 out of 1,000 units. This is a small number, but it is a serious safety issue. The foreign object was a hardened gasket piece, about 5 to 8 mm in size. Here is the failure mechanism. Too much liquid gasket was applied. The extra part overflowed and hardened. While driving, the piece came off and flowed into the cooling system. It got stuck at the thermostat inlet, blocked the coolant, and caused overheating. The gasket was applied by hand, so the amount and position were not stable. Also, visual inspection cannot see inside the engine, so the defect was missed. Target setting. Now, let's set our target. Our goal is 0 blockages caused by gasket pieces. We want to reduce the claim rate from 2 per 1,000 units to 0. We will build process control that does not depend on worker skill. We will standardize the gasket application process to prevent reoccurrence and keep stable quality. Root cause analysis, YY. Next, we do a YY analysis to find the root cause. Why did it get blocked? A gasket piece flowed in. Why was there a piece? The gasket overflowed. Why did it overflow? There was no control method. Why no control? It was hand work, and the discharge amount was unstable. Why was it not found? Visual inspection can't see inside. The real cause was no control of gasket application. The process was not standardized. This was the root problem. Countermeasures and implementation. Now that we know the cause, we made countermeasures and put them into action. Process. We used an automatic dispenser and jig to make the gasket amount, position, and bead width stable. Standardization. We updated the work instruction and marked no overflow zones. We gave extra training to operators. Inspection. We added endoscope inspection to check inside the cooling path. Design. We considered adding a filter at the thermostat inlet. Effect check. Next, we checked the results of the countermeasures. For 6 months after implementation, there were 0 market claims. In spot inspections, we found no gasket pieces. We also saved about 12 million yen per year in rework costs. This showed both quality improvement and cost reduction. Standardization and future actions. Finally, let's look at standardization and future actions. We will expand the automatic gasket application to all lines to remove process variation. We will use this case as training material and make operator training more systematic. Together with R&D, we are considering developing a gasket-less structure, molded gasket type. We will continue to improve both design and process.